Hi, this is Muri reporting from Berlin, and in this video I want to show you how to create this stacked bar chart with React and D3. So on the left side you can see that I have some data for different decades, and each decade has values for avocados, bananas, and eggplants. And stacked bar charts are really good to have a chart that can compare individual values over time, like avocados, bananas, and eggplants in this case, but also if you want to be able to compare the totals or the summed up values over time. So yeah, stay tuned. So in this video, we will be rebuilding this chart here from scratch. But unlike the video number 4, where we had built a bar chart with animations, we will not be focusing on the animations in this one, because I think it will be a bit too time consuming. But if you're interested in seeing that, just let me know. So this is my app component, and the app component basically just renders my stacked bar chart component, and then it renders these checkboxes you can see down here, and these checkboxes determine which fruits or vegetables are rendered in my stacked bar chart via this keys prop. And this app component also passes on the data we saw earlier and some colors so that we can associate these fruits or vegetables with some colors in our stacked bar chart. So this is my stacked bar chart component, the way it looks after I clean it up. And this is basically my standard boilerplate component that I have been using for this series so far. I hope you're familiar with that, but if not, I can give you a quick tour. I am basically just rendering this SVG down here and giving it a reference here with this use ref hook. And then I am accessing this SVG DOM element in my use effect hook, which gets called when the DOM elements have been rendered and every time anything in this dependency array changes. And this is also now where I apply all of my D3 magic. And as a bonus, I'm also using this custom hook use resize observer to get the current dimensions of my SVG so that I can have responsive chart components. So the first thing I want to do here is create the x-axis on my SVG. And you might remember from session 3 that axes need scales to function, and scales are responsible to map or scale values in our data array to pixel values on our x-axis in this case. So I'm going to start by importing scale band from D3, which will help us split our SVG into equally wide bands for every decade in our data array. So we will have 5 pillars in the end. So I'm going to start by creating our x scale, which our x-axis needs. And for that, I'm going to say const x scale equals scale bands. And this is where I now have to define the input and the output values, the domain and the range, so that we can map every year in our data array to a different section or portion of our SVG. And the domain needs to be an array of all the years in our data array. And that is why we have to say data map. And I want to return the year of every object in my data array. And I want to map all of these years to the range of pixel values from 0 pixels to the entire width of my SVG. So the X scale has now split our SVG into equally wide bands, and it will point us to the beginning of each portion or band depending on the year we pass. So if we pass in the very last year, it will return this band here and the beginning or the very left edge of that band. So the X scale I will now use to render our x-axis into the group element that I have prepared here. And to do that, I'm going to say const x-axis equals axis bottom, which we will import from D3. And this is now where I have to pass in the X scale that I have prepared. And to render our x-axis inside that x-axis group element, I have to say, hey SVG, grab my element with the class name x-axis and call my x-axis inside it. So like summon my x-axis here. So if I save that, you will see I have an x-axis. So this is not positioned correctly at the moment because the axis bottom just refers to the ticks being on the bottom side of the axis. And to correct that, we have to say, or we have to attach an attribute, the attribute transform translates 0 pixels to the right and the total height of my SVG to the bottom. So this will cause our x-axis to align perfectly. So by passing in our x scale to this axis bottom, this axis knows how long it needs to be by looking into the range. It knows which values it needs to render by looking into the domain, and it knows how to position these values by looking into the type of the scale. And because it is a scale band, it knows that we have split our SVG into equally wide bands, and it knows that it has to position them at the center of each band, where also our bars will be positioned. So before we can continue with the y-axis of our chart, we actually have to focus on the main part of this tutorial, the stacking part. And to do that, we have to import something from D3 called stack. And to explain how that works, I have to go back to my app component and look at the data. So here at my app component, we have the data, and each year has values for avocados, bananas, and eggplants. And we want to stack them on top of each other for every year. And that means we want to stack eggplants on top of bananas and bananas on top of avocados. And now imagine that each point here represents one pixel on our y-axis. And that would mean that the avocado starts at 0 and it goes all the way up to 10 pixels. And then would come the banana, and it would start at 10 and it would go all the way up to 30 because we are stacking them on top of each other. And then comes the eggplant at 30 and it goes all the way up to 60. And that is basically what the stack function in D3 does. It sums all of these values together and it creates these sequences of pixels from 0 to 10 pixels, 10 to 30 pixels, and 30 to 60 pixels. And these ranges, or these sequences, we then need to use for every section in a stack. So let me show you what I mean by that, by making use of this stack function and creating a stack generator by saying const stack generator equals stack. And I hope by now that you have recognized this D3 pattern, that basically everything in D3 is a generator function that returns a function which you then use somewhere else. So now we need to configure our stacking by explicitly telling our stack which keys we want to handle, which keys we want to stack on top of each other. And these keys we are actually receiving as a prop, and that is why I called it keys. We can just pass it in here. And now let's see what this stack generator does when we pass it our data we currently have. So let's say console log stack generator with our data. So this is what the stack generator returns. You can see we have one array here, which contains arrays for every key in our stack. And if I look at the avocado here, for example, then you can see I have these ranges or these sequences for every avocado in my data array. So the first avocado has this range from 0 to 10, the second one from 0 to 20, and so on. And you can even see the data that sequence or that range belongs to. And if I look at the banana layer, or this second array here, then you can see that the bananas will actually start where the avocados have left off. And this is basically what is happening. The stack function, or the stack generator, is cutting our data into layers which are getting stacked on top of each other. So these layers I just mentioned, they are also called series, but in this tutorial I'm going to call them layers because I think layers is a bit more approachable. So I'm going to save these layers by saying const layers equals stack generator with the current data I have. And these layers we now need to use to render our stacks in our stacked bar chart. So one thing to note, these ranges you can see here, they are actually not pixel values yet. I just told you to imagine that they are pixel values, but they are just the raw values which are stacked on top of each other. And we still need to transform these values into pixel values on our y-axis. So yeah, just imagine having 1 million avocados. You wouldn't render a chart that is 1 million pixels high, right? So now let's create this y-scale to map these values, these raw values we have, to pixel values on our y-axis. And yeah, to do that, we need to know what is the extent of our data. We need to know what is like the minimum value and what is the maximum value. And the minimum value is 0 for sure, but the highest value is always depending on the data, and it will be 250 in this case. And to figure out that like min and max dynamically, we need to make use of the max function in D3. So to find out the extent or the max value in my layers array here, I have to make use of the max function in D3, and that will help me with that. So I'm going to go down here and say const extent is going to be from 0 to max, and here is where I have to pass in the entire layers array and tell this max function where to look at in each layer. And in each layer, I want to look at what is the highest value there. So I have to do another max. It is a two-step process. I have to first look, okay, what is the highest value in this eggplant array? So this is 250. Okay, then the highest value in this banana array or layer is 130. And then the highest value in this avocado layer is 50. So this will first return me the highest value in each layer, and then each highest value will be compared to each other, resulting in the highest total value, basically. And yeah, that is why I have to call another max here with the current layer and look at the sequence in each layer. And in each sequence, I want to look at the second value, and that is why I have to say sequence 1. And yeah, let's look at the extent here and see what we get. And you can see here the extent is from 0 to 250. Yeah. So now that I have the extent, I can now create y-scale, which will map these values to pixel values on my y-axis. So somewhere between 0 and 300 pixels, because my SVG is 300 pixels high. So yeah, for that I'm going to say const y-scale equals a linear in this case, with the domain, the input values from the extent, and the range is going to be from the total height of my SVG to 0. So the value 0 will be mapped, the value 0 will be mapped to the very bottom of my SVG because the origin of my SVG is here, and the highest value of my data array will be mapped to the very top of my SVG, 0. So if you don't know the main difference between scale band and scale linear, with scale band we are mapping these explicit years to pixel values on our x-axis, while with scale linear we are mapping this continuous range of values from 0 to 250 to a continuous range of pixel values. And if I were to give this y-scale, for example, the value of 125, then this would also give me the middle of my SVG. And this is something that we cannot do with scale band because we are mapping these explicit years to pixel values, and we cannot handle years in the middle of the data we got. For example, we cannot map 1975 or 1985 to pixel values with our scale band because we didn't explicitly define it as an input value. Now that we have the extent and the y-scale, we can now also add the y-axis by copying this part here and saying const y-axis is going to be an axis left from D3. Here we'll pass the y scale and select our y-axis, and there's actually no transform required, and we have to call our y-axis instead. So if I save that, you will see we have our y-axis. So we are nearly there. We just have to render our layers now, which will form our 5 stacks. And to do that, we have to use the general update pattern. I hope you're familiar with that, but if not, please check out my very first video in this series. So to render these layers, I will say, hey D3, select all of the existing elements with the class name layer in my SVG and synchronize them with the data I am giving you here. And here I am going to pass in the layers array, because we want to basically create 3 layers of data which will form our 5 stacks. And and then I'm going to say, hey, dot join, so create a new group element for me for every layer, and then give them the class or the attribute class layer so that they can update later on. So now that we have our 3 group elements with the class name layer, we now have to render 5 rectangles in each layer. We have to render 5 rectangles for the avocados, 5 for the bananas, and 5 for the eggplants. So to render these rectangles for each group here with the class name layer, I just have to continue this general update pattern a bit further and say, hey D3, for every group element that you just created, please select all of the existing rectangles and then synchronize them with the data I am giving you here. And the data is not going to be something new, but actually the current layer from this layers array. And we can access it in a callback function. And what we need to now return is the new data source for the rectangles. And the data source for the rectangles is actually going to be the layer itself. So now we will render a new rectangle for each sequence inside of this layer. Now we can finally render these rectangles by saying dot join rect. So this will create a new rectangle for every new piece of data inside of each group element. And if I save that, you will see that we have 5 rectangles in each group that we now need to shape with width and height and x and y attributes. So I know that this double select all with the data can be a bit confusing, but just remember that everything that comes after this join is called for every group we have, so it is called 3 times. And this data function, where we pass in a callback function instead of some raw data, that is just used to access the data from the current group we are in, and just passing it on to the rectangles, the children of that group. So now we have to add all of the attributes like x, y, width, and height to these rectangles so that we can finally see them. And I will start with the attribute x. And what I now need to do is I have to grab the current year of the current sequence and pass it to our x scale, which will transform these years of each sequence to pixel values on our x-axis. And I can now write a callback function which receives the current sequence of the current layer as an argument. And here is now where I can return the x scale, where I pass in the sequence dot data dot here. So I have shown you those sequences earlier, but let me show you how they look like again. So console log dot sequence. So here you can see all of the 15 sequences in my layers that represent each rectangle which I now want to create. And you can see that the first 5 sequences belong to the first layer because they start with the value of 0 and go up to 50, and then come the 5 sequences for the second layer, and then come the 5 sequences for the third layer. And if I have a look at the very first sequence, which represents the very first avocado, then you can see that each sequence also comes with the data associated with that sequence. And that is why I can access the year of that sequence and pass it to my X scale, which results in that X attribute. And the first avocado gets the X attribute 0, and is then positioned at the very left edge of the very first band or stack. And by getting the bandwidth of that band, it will form a stack. So all of our rectangles have the same width, and adding that bandwidth to our rectangles is pretty easy. We just say .adder width, and then say xscale.bandwidth. So our xscale has split our SVG into equally wide bands for every data in our original data array, and we can access that bandwidth by saying .bandwidth like so. And then you can see that our rectangles each have a width of 100 pixels. So now we need to add our y attribute to each rectangle, and we do that with the help of these values and the y scale that we have used to create the y-axis, which will help us to position or transform these values into pixel values on our y-axis. So you might remember from one of my previous videos that the origin of a rectangle is in the top left corner, same as the origin of the SVG, and that means that the width attribute of a rectangle goes to the right and height attribute goes to the bottom, and that means that the y attribute of a rectangle needs to be the top edge of our rectangle, and the top edge is determined by the second value in each sequence. I'm pretty sure that was super confusing, but if you have any questions, please let me know. So by passing these second values, the top edge values of these rectangles, to our y scale, we can now transform them into pixel values on our y-axis. And we do that by grabbing the current sequence and passing it to our y scale as sequence 1. So this will grab the second value in that sequence. And if I go to the Elements tab, you can see that each rectangle now has the correct y attribute. So the height attribute of each rectangle we can calculate pretty easily. It is just the difference of pixel values between the first value here, the bottom edge, and the second value here, the top edge of our rectangle. And we just do that by saying .adder height, and we grab the current sequence and then return y scale sequence 0, so the bottom edge, minus y scale sequence 1, and that is the top edge. Now we have some stairs. So let me just quickly add some padding between my bars by saying .padding 0.25, for example. And it might look like a basic bar chart now, but what you cannot see are the different layers of my stacks. And that is because each layer currently has the same color, and they're all black. So I want to now colorize each layer, every rectangle in each group, and to do that I will go to my group elements that I create here, and I will add another attribute, the attribute fill, and the fill attribute will now influence the fill color of each rectangle in that group. And that is going to depend on the current layer, which I will access in this callback function. And let me show you how that layer looks like by logging it out, console log layer. And here you can see the 3 layers, and this is the avocado layer. You can see it has the key avocado. And then comes the banana layer, and so on. And these keys I now need to pass to the colors object that I have passed to my stacked bar chart. And so to grab the color, I have to simply say return colors layer.key. Ta-da! There we have our colored stacked bar chart. So one more thing before I wrap up this video. We now have these 5 stacks consisting of these 3 layers. One layer for each key we have defined here. The avocado layer, the banana layer, and the eggplant layer. And if I now click away the avocados, the keys prop we are passing to our stacked bar chart updates, causing our stack generator to generate completely different data. And this is why we only have 2 layers. And if I now re-add the avocados, you will see that they will appear on top. And that is because the key avocado is pushed to the end of this keys array, and that order inside of that keys array is maintained also in our stacks. And we can actually influence the order of these layers by adding another function to our stack generator. We can just say .order and pass in an order function that D3 provides out of the box. And we can, for example, choose order or stack order ascending, which will cause the layers with the lowest total sum to always appear on the bottom. So you don't have to worry about the order or the arrangement of the keys in this keys array. So yeah, that's it for this video. I hope you liked it. I totally underestimated the time I would need for this video, but I hope it was worth your while. So yeah, let me know what you think. See you in the next one. Bye.